And welcome back. Now today we're going to be looking at a very small audio module that can be used in just about any situation where you've got a microcontroller. So today, as you can see on the workbench, we've got our little Arduino, well that's a Nano actually, plugged into a development board, and we've got the Raspberry Pi at the back, to which it's plugged in at the minute. Now, what is this little module? Well, as you can see just about from the name there, which is that one there, ISD1820. Now these units are available for just under £1 at the moment from eBay, Chinese suppliers obviously, and AliExpress I think probably do them as well, can't remember now off the top of my head. So let's have a look about what it does. Let's have a look at the browser module. Here we are. Now this is the actual data sheet as supplied by the manufacturer, so ISD themselves. Now if we just whip through that, being a data sheet, yes I appreciate it is a little bit dry reading, but it does tell you everything you need to know, but there's an easier one coming up. So this tells you about various playback scenarios that you can have, you know, how many seconds. Here it says you can have 8, 10, 12, 16, and in fact at the moment and out the box it comes with 10 seconds of recording time. The speaker that comes with this unit, currently hidden by the loo roll. Yes, we're going to need that loo roll in a minute. This little speaker, if you buy that with it, and adds an extra 30 pence or something onto the price. I got it just for completeness. I do have another speaker, I'll come on to that in a minute, but it didn't make an awful lot of difference. I suspect the limitations in the chip itself. But as you can see here, look, 0.5 amps, microamps standby current, which is, well, I would have thought the leakage current of the battery would be more than that. And, oh well, that's always good to know that there's a 100-year message retention and 10,000 record cycles, none of which I suspect any of us will ever get to that limit. So, okay, that's the dry data sheet, and there's a lot more of it going on, whole page after page after page. And to be quite honest, if you get the module, it's just worth reading it. There's a nice little circuit diagram as well, really. That will make it easier to understand. But that notwithstanding, if we have a look at the slightly easier one to look at, which is, so here's a slightly easier one to read, let's say, and it's a bit more practical. There's that. Ooh, look, there's a circuit diagram again, and it just tells you what you can do and what you can't. That's all there is, 3 or 4 pages, and lots of that is photographs. So that's fine. Let's see what the module actually does though. So back to the workbench, and then we can talk about it from then. Now bear with me because I'm playing about with various cameras, microphones, you name it, it's all go here today. So I'm going to flip to my other camera, because then when I turn round I can look at you straight in the eye. Cool. So what we're looking at today then is this module here and what happens when you press any one of these 3 buttons. So if I press this button here, and I'm not going to use the loo roll just yet, so let's take that out of the way. Now I do have a separate microphone which you might be able to see. So look, there are a separate microphone which is necessary because otherwise you wouldn't hear it. So let's press the button.
Attention, there is a problem with the heater in the workshop. Please investigate.
Now to my ears, and I'm about I don't know what, 40-50 centimetres away, 1.5 foot, it was very quiet. It wouldn't be enough. You'd hear that something was being said, but you couldn't work out what it is. However, if we place a tube like this loo roll on top of it, and what I'm going to do is put the microphone near the top now and press that button again.
Attention, there is a problem with the heater in the workshop. Please investigate.
Investigate, indeed. Now that time I can hear it quite clearly, and I'm thinking that in real life this speaker would indeed be mounted on a baffle plate like this, basically your enclosure. That's what that would be well, mounted into, I suppose, after sellotaped it on the back. But then I thought, well, maybe the tube is also required because that volume wasn't really enough without it, so you might have to mount it in a piece of I don't know, plastic waste pipe comes to mind, 1.25 inches, 1.5 inches, something like that. And it wouldn't be difficult to do, because if you didn't do any of that, then you're going to have to basically put an amplifier like this, and that sort of detracts from the whole idea of this easy to use module. Now, I did have another speaker like this one here, which I've had around for a little while. That's a 4 ohm 3 watt, and I've got something very similar to this one built into Benny's rain monitor and temperature sounder. And that sounds, because it's being driven by the MP3 player in that video we did quite some time ago. There it is, that's the one on the screen now. So that's being driven from the MP3 player, and the volume is much louder, and it's on a speaker like this, and I'm not kidding, you'd think I was standing in the room when the announcement goes off. So the MP3 player is obviously louder, but putting this speaker in place of this one here didn't really have much effect. Yes, alright, it was a little bit better quality, less scratchy, but it didn't make it any louder. Now this isn't a 4 ohm, you can get 2 ohm speakers, but I suspect that wouldn't help either. So just bear in mind that the volume could be a little low.
Attention, there is a problem with the heater in the workshop. Please investigate.
Very audible with that tube on, not so much without it. Okay, so we have the 3 buttons down here. The red button, as you might imagine, is for recording. That's for playing the entire message, and this final one is only for playing the message as long as you keep the button held down. So I press it. As soon as I release my finger, the message stops. All well and good, and oh yes, it has a built-in microphone, of course. Where's my little pointy thing? Alright, so there's the microphone, and it's got AGC built in, so you can talk at it from about a foot. That's how I recorded that message. Well, obviously it wasn't my voice. I'll show you how to do that in a minute. So that microphone is quite sensitive, and it works well as it can do anyway. And as I said, we've got this at the factory default of 10 seconds recording time. Now if you want a slightly better quality, you have to desolder one of the onboard SMD resistors and replace it with a different value, or potentially have a variable resistor so you can adjust quality versus time. I haven't tried that because I thought, well, if we're going to use this in any kind of situation, the last thing we want to do is muck about with resistors. Yes, I'm sure some of you probably will want to do that, but I thought no, we'll just leave it as is. So that's all very well, it's all connected up and we can press the buttons and it works. Now I'm going to put the tube back on. I hope it does actually amplify the sound. Move the microphone down a bit. Let's press it once more.
Attention, there is a problem with the heater in the workshop. Please investigate.
Now I can hear that quite adequately. If it's a little bit quiet on the video, I'll boost it when I come to edit this video. But what I want to show you now is how we can trigger this using either the Nano or the Raspberry Pi. Dead easy. All it needs on one of these pins on the left is a rising edge, basically a Gpi pin that goes high. Let's try that then. So this is my VNC into the Raspberry Pi. Now if I, there we go, here I'm back. There's the workshop top rather over there, and this is the Raspberry Pi, what you see. So in order to fire up the Raspberry Pi Linux, we just go to programming, Python 3. They've kept Python 2 on there for backward compatibility, but we won't be using that, and you shouldn't either really. Python 3 is the way to go. So Python 3, now that's going to bring up a shell, and if you've noticed I've worked out how to get the window a little bit smaller this week. So let's get the file that I wrote, a recent file, and it is sound module. Here we are. Now I've actually put Gpio22 just to remind myself which pin it was that I'd allocated. So let's just bring that up into shot. So this is pretty much the simplest sketch you can get. I keep saying sketch, I'm not sure it is the right word for Python. I must find that out. The Python program anyway. So what are we doing here? What exactly are we doing? Well, first of all, we're importing here the pins, the GPIO pins, the fact we can actually write to them and read from them, because by default they're not loaded. Now I declare here which pin it is we're doing the output on, which is pin 22, and as you can see this is very different from Arduino world, where you'd actually do a define or potentially declare an integer with a value or something like that, but here you just declare a name and set it to a value. All well, it's not strongly typed, you see, so it's a bit like JavaScript. It becomes whatever you tell it to, it becomes. So because we're allocating a number here, this is now an integer, but we could equally assign a string to this, and then that would become a string. Okay, so what we're doing here then, now in a try catch loop, but we'll come into that in a little bit. So this while true is a little bit like the Arduino loop, just do it forever. We're setting the output mode on the pin, on all the pins, to, well, what's called BCM. That's the Broadcom numbering convention rather than the board numbering convention. Yeah, I know it's a bit confusing. Let me show you what I mean over here on the workshop again. Oh, that means I really must get this automated, all this camera faffing about. So there we are, I'm over here now. So on here you can just about make out, and of course I've got to check now by looking over my shoulder, it's on shot. You see this little board I've got on here, that basically slides over the pins here so we can tell what each of those pins does, because otherwise they're just numbered and you've no idea. So the convention is to use the pins as in the Broadcom chip numbering system rather than the board 1, 2, 3, 4, 5 serially, because, well, I guess the board pins could change at any time, but the convention won't. They'll always stay the same. In fact, there's a little web page in the one of the Pi websites. I'll show you that in just a sec, exactly what we're going to be using. So this is a fairly typical web page, of which there are a zillion, explaining the GPIO board and BCM modes. This is quite a nice one though, because it gives all the pins here, and then down the bottom it explains the difference between board mode and BCM mode, and explains that using one set of numbering here and a different set here actually addresses the same pin. But we're going to be using BCM because that does seem to be, well, I don't know if it's a de facto standard or not, but certainly the examples I've seen so far, it makes sense to use those. So that's what we're going to end up with. If anybody knows different, do leave a comment below. We'll revisit this entire subject. I'll put a link to this page though in the video description so you can have a good look at it. So that's what we're using. Right. So what we're saying is then, in the actual, for that pin now, which is defined up here in 22, we're saying it's an output pin, and we're setting it 1, which is high. Yes, I could have defined that 1 up here as high and low and things like that. Would make good sense actually to do that. So we set the GPIO pin high for 1 second because we sleep for a second, that's like a delay. Then we set it low, and then we sleep for, well, 30 lots of half a second. Why 30 lots of half a second? Why not just 15 seconds, for example? Well, whilst this sleep is happening, nothing else happens at all, which is quite disconcerting. So if you want to stop a program running on the Pi by pressing Control-C on your keyboard, so while things are running in here, nothing happens during a sleep. So you could have a situation where you've got 15 seconds and nothing is responding. However, if you do it this way, you say 30 lots of half a second and then it runs around. If you've pressed Control-C while this loop is running, then the maximum you'll ever have to wait is half a second. So this is where we have this try and then the accept bit, which is keyboard interrupt. That's the Control-C. I just display this message, and then we do a Gpio cleanup. What does that mean? Well, we can experiment with that in a minute. Let's just say it sets the pin mode back to what they were before we started fiddling about with them up here. Okay, and there's a good reason for doing it. But let's just run this for the time, and what should happen is that over there on the workbench with the loo roll, that should suddenly spring into life and start sending that message. If I move the microphone a little bit, whoops, I'll move it a little bit lower. Okay, and we'll see what happens. Right, to get it running, all we have to do is press F5, and...
Attention, there is a problem with the heater in the workshop. Please investigate.
So look at this warning here, we'll come on to that. So it's done it now, and it's now whizzing around this loop for 15 seconds, and after 15 seconds it goes back and does it all again. There we are.
There is a problem with the heater in the workshop. Please investigate.
Okay, so it's running. Now if I press Control-C, now you see that almost instantaneous response where it says program terminated, and that is what I've printed out here. This warning here has happened because I've been fiddling about, and what it's saying is when it gets down to pin 22 in here, it's saying right, we're going to do all this stuff here. Because I've been fiddling about and doing stuff with it this morning already and not doing a Gpio cleanup, it says, oh, hang on a minute, I'm still aware that pin 22 has been assigned a function or an output mode, and it's not what it is at the moment, or it's in use already by something else. Let's put it that way. This is why we do Gpi Cleanup. That is indeed exactly what it does. It cleans up the pins and states back to what they were. But only the ones you've touched, though. Obviously, if you've got 2 or 3 Python programs running, hopefully all using different pins, pin 22 wouldn't be touched by another program when you do a Gpio cleanup. It only sets the pins back to default for the ones you've actually fiddled about with in your program. So if we run this again now, because obviously it's done the Gpio cleanup, so if I press F5,
Attention.
this
There is
time,
a problem with the heater
no
in the
warning.
workshop. Please investigate.
And we can terminate, and that's that really. So do remember to do the GPIO cleanup, and of course once you get this warning out, it'll become pretty apparent that's what's happening. Okay, that's fine. It's straightforward. There's nothing special about it. It's just a really simple program running in Python on the Pi. What about our little Arduino then? Our little Nano's sitting over there getting quite bored waiting for us. So I think I'm going to connect that up and just show you how easy that was as well. Right, this is the trivial program that we're going to run on the Arduino IDE now, just to trigger that module. And let me bring that into shot because we're not looking at the Raspberry Pi anymore. We're now looking at this little Nano connected up here. Now, one thing I didn't mention, that this little board here is in fact 3.3 volts tolerant. You can run the power supply up to 4.5, but all the input pins are 3.3 tolerant, so it works well both for Raspberry Pi and the Arduino, which you'll see in a minute when I connect it up to my USB. So what's this circuit doing? Well, it's almost an identical port of the Raspberry Pi code. We're defining here a trigger pin, this bit here. Remember the Pi didn't need this defined, it just declared a variable, but we're actually defining it as a substitute value. The setup, we're doing the serial output, although we're not actually writing anything to the serial output window apart from startup complete. And I would say, you guys, that when you write your programs, do include the serial output, because then all you got to do is click that little button up there. You'll get a serial monitor or debug window, as it's commonly known, and you'll be able to follow stuff through in your program, because a couple of the code examples that I've been sent recently, I'm not surprised that you got a bit lost amongst your code because you couldn't tell what was happening. You couldn't tell where your code was. By putting in little lines like this at various points of your program, you'll be able to debug things a lot easier, believe me. So I'd highly recommend that. Anyway, all we're doing here then is we're setting the trigger pin low initially and then setting an output. Now you might be asking, oh, hang on a minute, Ralph, that's an odd way of doing it, isn't it? Shouldn't we set it to output first and then low? Not in this case. Because remember, the minute you set it to an output, that pin could have a pulse high before it gets set low, and that pulse would be enough to trigger that module. So by setting it to low first and then setting it to output, there won't be anything on that pin, not even for a nanosecond. Okay, because that has caused problems in some of the forum questions I've seen, where that pin goes high just for that fraction of a second before going low. So just by doing it the other way around, that's fine. Okay, so in the loop, all we're doing is setting it high. We're having a tiny little delay of 100 milliseconds here. That's 1/10 of a second. I think on the Pi we had it for 1 second, didn't we? But it doesn't matter. Then we're setting it low and waiting for here 10 seconds. Now for us, well, there is no sort of interrupt key or anything like that for the Arduino, is it? The code is embedded directly in that chip, so that's where the comparison really sort of breaks down between the Pi and the Arduino. But that's as simple as it gets. That is the entire program that you're seeing there, apart from the comments at the top. Oh yeah, I've explained here how to actually do that. So let's just switch on the USB. We should hear a little noise from Windows, and oh yeah, and then it should trigger the output. Oh, you can see the Arduino flashing there.
There is a problem with a heater in the workshop. Please investigate.
Right, let me switch on the microphone. You probably hear it a bit better actually.
Attention. There is a problem with a heater in the workshop. Please investigate.
Right, we will indeed at once. Okay, so that's working, not a problem. I mean, it's simple enough. The module itself, let's all right, but thank you. Yeah, thank you. We've heard enough now. Let me switch that back off again. Right, so let's have a look where I got this from then, because you might be well interested in this. Basically, my thinking is that for just under the £1 it was. Well, I paid £1.27 because I included the speaker, but I might play about with that speaker a bit more or try a couple of different ones out. But basically, for just under the £1, I could put a module or 5 like this into my workshop automation and have it say some pre-recorded voice. And it doesn't have to be in my workshop automation, of course. Say, for example, you had a power supply or something, and it could say, current exceeded, please check. Anything you like, it doesn't matter. The point is, for £1, I think it's well worth investigating. So let's go to the browser and have a look where I got this from. Right, this is the one I got. Yeah, it says 99 pence, but that doesn't include the speaker. So if we, in fact we select on there, you get an option. You can't see the drop down, unfortunately, due to the way the screen capture is working, but you either get that module that you can see there with black buttons, or with the red button, as I've got it there in that picture, and with a loudspeaker, and it is £1.21, in fact, not £1.27, got that wrong. And that's sold by Chips Fans. I've used Chips Fans quite a few times, and they're pretty quick. I've got to say, this probably took, I don't know, just over the week, 10 days, something like that. I can't remember now exactly, but anyway, they're pretty reliable. So that's come with an 8 ohm speaker, as you can see there in the picture. 8 ohms, 0 point something. I don't know, on my one it's rubbed off, so you can't actually see what it says. So that's where you get it from. And I'm sure if you went to ebay.com for our American friends and Canadians, and probably Australian as well, there's the Chips Fans sales everywhere. It's from the Far East, so they're on all their platforms. Right, how did I get that voice on there? I hear you cry before you leave me. Right, okay, that voice obviously wasn't my voice. It was a woman's voice, and it was a British voice. How did I do that? I'll show you that next. So this is the online voice generator that I've used. In fact, if you look at on the left hand side here, some of these options, they're really quite interesting. They can test your hearing, show you how deaf you are, like me, all speaker tests, the whole lot. But the one thing I'm looking at is this voice generator, and what it does is speak this spoken text or anything else you type in here, and you can have some fun with different accents as well. So although at the moment it says Microsoft David Desktop, it's actually not. Now what you can't see is the drop down list when I click that, which is a bit awkward. So let me go to the monitor. So you'll see my entire monitor, but I'll have to clean it up first, as you'll get confused about what window we're looking at, and then we'll continue. Right, that's better. Now we can see exactly what's going on. I've got rid of the adverts and everything else. So what you see then is when I click this drop down list, you get all these different things. It seems to be duplicated sometimes, but whatever. I was probably using the Hazel Desktop English Great Britain. Let's try that again, shall we?
Click the play button to hear this sentence spoken out loud. You can change this text to whatever you want.
That wasn't the best English rendition of text I've ever heard, I must say, but there are better ones. So let's type in something else. I hope it can knows what an Arduino is. Let's have a look. Right, let's change the speaker now to, here we are, Google UK English Female. Maybe that was the one I was using in my test.
Arduino is the best platform for embedded software.
Not bad, not bad. Try that again.
Arduino is the best platform for embedded software.
Yeah, that's acceptable. Now, of course, there is an American version. There's Zira. Okay, love, play along.
Arduino is the best platform for embedded software.
Acceptable. Now, you can have a bit of fun, actually, by putting foreign accents on. So you can have Google Deutsch.
Arduino is the best platform for embedded software.
Ja, so das ist richtig. In fact, if you type in a bit of German here, then the accent does match the language that you put in. So if I said Guten Tag, hier, spelt wrong, hier ist es sehr warm. Heute. Right, so that's German, and when I click this, even though it says David Desktop, it isn't, because it's the one we previously selected.
Guten Tag, hier ist es sehr warm heute.
Much better. So, and you can try Spanish and Chinese and all sorts, right? And you can either have fun doing it or actually use the right language for the text that you're actually typing. Now, the big question you're probably going to ask is, how do you get that spoken word into your computer or anything else? Well, basically I just took the device and held it up to the speaker. Nothing special about that. So basically this little thing here with the embedded microphone at the back, I'll just pick this up. I mean, it's just blue tack to my board at the moment. So when it was powered up with 5 volt, no, not 5 volt, 3.3 volts, I just put this next to the speaker, a bit like my other microphone is at the speaker at the moment, and recorded it, and it's more than adequate for what you want. That's the way to do it. Yeah, so that's it. So you can type in anything here, have loads of fun with that, record the bits you want. When you hold down the red button, it starts recording, and you can keep speaking, but just try and time it for the 10 seconds or less, because when that light flashes, it stops. So we're going to actually try that now. I'm going to flip around and press that button and say something different. So I'm going to press this button. You'll see a light come on at somewhere along here, and then then I'm going to start shouting at it and you'll hear it. Arduino is the best platform for embedded software. And all you've got to do then is press the playback. Arduino is the best platform for embedded software. Easy. How easy do you need it to be? Okay, well, I think that wraps it up rather nicely, and I'd say that's it. Go and have a look at the eBay or indeed any one of the Far Eastern websites. I'm sure they've all got this module. ISD1820. Think about where it could be useful in your system and have a play. And if you like the video, do give me a thumbs up, and don't forget, write some comments below if you feel like it. The more comments you write, the better it is for me, because then YouTube says, people are interacting with this video, so that'll be good. Okay, and also don't forget to visit that other website, okay, for pets, cats and dogs. It's all in the video description down below. Great stuff. Thanks for watching, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.